Well, we have a question here. Question 1.1 says solve for x, and then question 1.1.1. I'll write the question over here. 1.1.1 is x squared minus x minus 12 equal to 0. So now the question says we need to find the value of x. Okay, solve for x. So calculating the value of x or the values of x. Now, as we can see the question here, this is a quadratic equation or a trinomial, okay? We can solve this by factorization. We can solve this by solve this by using the quadratic formula. Now let's first solve the problem by factorization. We do have x squared minus x minus 12 equal to 0. Okay, so by factorization, to factorize this, we first going to look at the leading coefficients of the leading coefficients is the coefficient of x squared. When you look at x squared here, usually people say there is no coefficients because they don't see anything, or others say it's 0. Well, none of them is right. When you don't see any number in front of the x squared, understand that it's 1, okay? The leading coefficient is 1. Now, what you're going to do, you then going to, if the leading coefficient is 1, all you have to do is to put x in the brackets like this, okay, equal to 0. Now, you are going to consider the last term, the constant term, which is 12, actually negative 12. Now, we're going to list all the factors of 12, okay? Preferably in ascending order. I know the number is negative 12, but then list the factors of 12. They are like 1 and 12. I say 1 and 12 because 1 times 12 makes 12. 2 and 6 is 2 and 6 because 2 times 6 is 12. 3 and 4 because 3 and 4 it makes 12. Those are all the factors of 12. Okay. Then in the list of the factors of 12, there must be only one couple, exactly one couple, which will make a sum equal to the coefficient of the middle term. The coefficient of the middle term here is -1. Okay, now let's see. With 1 and 12, we will never get -1, neither will 2 and 6 make -1. But with 3 and 4, yes, they will, if we have +3 and -4. Therefore, in the brackets here, we're going to write +3 and -4. Okay? Then there's a property in mathematics that says if you have like a times b equal to 0, it means that we can write a equal to 0 or b equal to 0. Okay. Then this means we can do x plus 3 equal to 0 or x minus 4 equal to 0. Then we can solve for x. When we move the positive 3 over, with x is equal to -3, like the value of x, or x is equal to 4, but also a value of x. So those two values are the solution of this quadratic equation. It means if you sub -3 here, wherever you have x, the answer will be 0. If you sub 4 there also, you're going to get 0. You can check it yourself. You can check sometimes to make sure your calculation is correct. Now that we solve by factorization, we can solve the same problem by using the quadratic formula. Quadratic formula. Okay. The quadratic formula is when we do know that the quadratic formula is given by x equal to, it calls also the root, is equal to -b plus minus square root of b squared minus 4ac all over 2a. While the quadratic equation itself is ax squared plus bx plus c equal to 0. So now we have to identify the values of the variable a, b, and c. Okay, we can see from the equation that a here is the coefficient of x squared, b is the coefficient of x, and then c is the constant number. So now we can see that a when you look here, when you look over here, A is just 1. Okay, so there we're going to write 1. B is -1. And then C is -12. Not 12, but -12, because we need to take numbers together with the signs. Now we're going to substitute that into the quadratic equation, in the quadratic formula. So it's like -b plus minus square root of b squared plus 4ac. Okay, that's the quadratic formula all over 2a. Then we can sub in the values. Okay, b is -1, because that was the place for b. Okay, square root of b squared. I'm looking at this formula over here. Square root of b squared. B is -1, a is 1, and then c is -12 over 2a is 1. Then we can just substitute this in the formula. We can do it in the calculator. Let's see. That will be like I'm gonna write here negative open brackets, -1 close bracket. Because there are two solutions over here, we have plus or minus. I cannot do plus or minus in the calculator, but I can just work out the first solution. Plus square root of negative of b, so -1 to the power of 2, plus, I say plus there, but I meant minus here. It's minus 4ac, okay? Minus 4ac. So I meant minus 4a, and then c, which is -12, close bracket, all over 2a. So 2, open bracket, a is 1, close brackets there. When you press equal, enter, equal, and then we have this. So we have two solutions. The first solution is with the positive x is equal to 4. With the positive, that's the 4 we have here. You see? Now we can also work out the same solution, but we're going to change the negative sign over here. So now when I go back to the calculator, we can just press delete here, and then minus, and then press equal, and then the answer is equal to -3. X is equal to -3. That's the very -3 we got here. Okay, so our x is equal to -3. We can also solve this same problem by using by completing the square. Okay, maybe let's just do it over here. You can also solve by completing the square. I know most people don't like it. Completing the square. Most students have been prefer not to use solve by completing the square, but just do it for fun. By completing the square, it's like, okay, let me make it easier for you. It's when we change the constant term into the form of b over 2 to the power of 2. You'll see why. Okay, we have like x squared plus it was so minus x minus 12. Okay, that's what was the question. Excuse me. Yes, x squared minus x minus 12 equal to 0. Now you use this formula only when a equal to 1. Okay. So first thing, we're going to, you could notice that c, which is the last value, the constant, which is 12, is not a, okay, is not making, we want to make 12 a constant number such that here we have a perfect square. Perfect square is written like this. It's of the form like ax plus b to the power of 2. That's a perfect square, okay? But we cannot write this way with a negative 12. We cannot make it a perfect square here. So what we do, we're going to move negative 12 over. It becomes positive 12. Then over there, I want to find that c value. So I'm going to do it. C will be b over 2 to the power of 2. So b is negative 1, right? Negative 1 over 2 to the power of 2. Okay? So this is which is equal to a quarter. Now, what I'm going to do next is I'm going to write here plus, I'm going to add negative half over here to the power of 2, and then I'm going to add the same quantity over on the other side of the equal sign. Excuse me, my voice. I'm going to add the same quantity on the other side. That will be, okay, instead of me writing negative half, I prefer to write a quarter. You understand why? So a quarter. Okay, this exponent is a little bit far. Okay. Now, this value, then this c value that you got here is the value that will make the right-hand side of the equation a perfect square. So when we only consider the bases, we consider x and negative half, we're going to take the basis of the first and the last term. It's going to be x minus a half. I keep the number of the signs, okay? Equal to 12 plus a quarter, okay? So now, usually I got this question from students. What about the negative x? Where did it go? Okay, the negative x is included here. If we expand the right-hand side, we will get x squared minus x and then minus a half to the power of 2. Okay, so it is somewhere. It is somewhere here. Okay, it is in that product. So now over here, 12 plus a quarter, I can write 12 in exponential form. So I mean not exponential form, but I need to make a denominator of 4. So I'll write here 12. 12, because 12 is like over 1. Excuse me, 12 is like over 1, right? So if I need to make it with the denominator of 4, I'll times by 4, the denominator times by 4, also the numerator times by 4 there also. So I have like plus a quarter. And then this will be x minus a half to the power of 2, and this is equal to 48 over 4 minus a quarter. Now this will make x minus a half to the power of 2 equal to excuse me, that's a plus. That makes 49 over 4. Now, if I need to find x, then what I will do, I can simplify this further. 49 over 4. So what I can do, I can just introduce the root. I can just square root here, square root this part and square root that part also. Why square root? Because the square root will cancel the power of 2. And then I'm left with x minus a half equal to, okay, over there it's like, okay, at the moment that we put the square root, understand that when we have an equation, meaning variable and numbers and the square root, understand that this part will be plus or minus automatically. Because let me prove you. If I tell you what is 3 to the power of 2, you tell me it's 9, okay? What is negative 3 to the power of 2? It's going to be still 9. Meaning square root of 9 can be 3 and negative 3. But this is when we have a variable, okay? When we have an equation. Now, where were we? So square root here, okay? This square root. So this will be like square root of 49 over square root of 4. And then we can move the negative half over. That will become positive half plus or minus. The square root of 49 is 7, and the square root of 4 is 2. And then here we have two solutions, okay? One with the positive and the other with the negative. So we can just, because the denominator are common, the fact that the denominator are common, we can just add the numerator, okay? So this will be okay, let me write. X will be equal to 1 plus 7 over 2, or x equal to 1 minus 7 over 2. Well, here it means that x is equal to 4, one solution, and there x is equal to -3. So you notice that using decomposing the square, we got the same answers as we were doing the quadratic formula and by factorization. Thank you.